Now let us find out the angular velocity of connecting rod. Let the angular velocity of connecting rod be omega c. Omega is used, we have used omega for crank. So we are using omega c notation for connecting rod. If you look at the mechanism here, the connecting rod is like this. So at one point, this end point is making a linear motion, whereas this point C is moving along a curvilinear path or circular path here. So the connecting rod is actually having a motion like this, like how this pen is moving. The motion of connecting rod is something like this. So it is not just a linear motion. So there is also a curvilinear motion of it. So that's the reason we are taking omega c. We are considering its angular velocity. So let it be omega c, and omega c can be found as d phi by dt, the rate of change of angular displacement. What angular displacement will it make? The angle it is making with respect to line of stroke is phi. Like how omega was d theta by dt, like that d omega c will be d phi by dt. So we are writing omega c as d phi by dt. And similarly, we will use alpha c as angular acceleration of connecting rod. So from equation A, we have equation A, n is equal to L by R, or we also have another equation. So from our previous derivation of displacement of piston, we have got sin phi is equal to sin theta by n. Let this be an equation number A1 say. So from A1, we have sin phi as sin theta by n. So now differentiating both sides with respect to t, because we want this d phi by dt. So we are doing this. So d by dt of sin phi is equal to, anyway n is a constant, but d by dt of sin theta by n. So this I can write by chain rule, d by d phi of sin phi into d phi by dt is equal to d by d theta of sin theta by n into d theta by dt, because we know we don't have the terms, we are not dealing with the terms involving phi with respect to t or theta with respect to t. So for our easy math work, we are using the chain rule. Using chain rule, we are writing in terms of the differential variable only, which we have to differentiate. Here we have phi, so we are taking d by d phi into d phi by dt. Here we have theta, so we are using theta. So now d by d phi of sin phi will be cos phi, and d phi by dt is nothing but our omega c. This is omega c. Now similarly, n is a constant, so I can bring it outside, but d sin theta by d theta is cos theta. This is cos theta by n into d theta by dt is omega, angular velocity of the crank. So from here I have omega c is equal to omega cos theta by n cos phi. So this is one expression. So now, as we know, from equation number B, which we have obtained in displacement of piston, here we have equation number B, where cos phi is written in terms of theta. So I can substitute from B, I can substitute cos phi. For cos phi I am substituting this. So we get omega c is equal to omega cos theta by n into root over n square minus sin square theta by n. So this n and n gets cancelled. So I will be remaining with omega cos theta by root of n square minus sin square theta. Like in the previous case, when we have found velocity of piston Vp, we got something similar to this, root of n square minus sin square theta. But as we discussed, as n is greater than 1 and naturally n square is larger than sin square theta, we omitted this sin square theta, we considered it to be 0. So similarly we will do the same here also. So n square is very much greater than sin square theta, so sin square theta is assumed to be 0. Then we will have our omega c, the angular velocity of connecting rod, as omega cos theta by root over n square is nothing but n. So let this be equation number 6. This is the expression for finding the angular velocity of connecting rod.